Large language models are biased because they are large language models. I've often told my students that a conference talk is an advertisement for the paper. This video is an advertisement for the full article that appears in the Computational Linguistics Journal. Its main point is that there's a discussion our field really needs to be having that we aren't having. Well, let's see if I can get you interested in having it. First, what's a language model? It's just a way to define a probability distribution over strings of symbols, for example, words. That's all a language model is. Using the chain rule of probability, that distribution can give you the conditional probability of the next word given the previous context. A large language model is, first and foremost, just a language model. But there are three additional things to highlight about them. First, they're trained on a huge quantity of human language. Second, training them optimizes cross-entropy, which in plain English means their ability to do a good job at word prediction. And third, these are generative models. That means that in addition to modeling the observable language, they're implicitly modeling latent internal structure, which I'll call X. No matter what bells and whistles you put on top, the fundamental operation and nature of these models comes down to a joint probability distribution that's driven by that latent X, which is learned from the language that people have produced. Now, the reason these models are so effective is that inside their latent X, they're doing a great job modeling what we can think of conceptually as the human latent X, the underlying human conceptual structure that gave rise to all of that observed language. Within that structure, for example, words like king and queen are similar to each other because they're both royalty, and they're also different from each other, with the difference being along the same dimension as the difference between man and woman. This example comes from Word2Vec a dozen years ago, but the huge power of today's LLMs is just the same thing on steroids. They're doing an amazing job capturing relevant underlying structure in the human X, which is to say the incredibly complex underlying structure of human existence in societies. The problem is that within the underlying structure of human discourse, there are a whole lot of things that suck. Along with syntax and naive physics and biological taxonomies and the conventional structure of fairy tales and all kinds of other generalizations that are useful, we also find bigotry and misogyny and extreme nationalism. We find homophobia and the treatment of misinformation on par with facts. And the very core of the problem is this. LLMs have no way to distinguish the stuff that sucks from the stuff that doesn't. Consider these three statements about nurses. A nurse is a kind of healthcare worker. A nurse is likely to wear blue clothing at work. A nurse is likely to wear a dress to a formal occasion. These are all true statements at this point in time and history. But they're also different. The first one is a fact about what nurse means. The second is a contingent statement that's normatively acceptable. Nobody would be upset by an image classification system using blue clothing in an image to label it as a nurse. The third is non-normative, though. It's not okay normatively to assume someone in a dress is more likely to be a nurse than someone wearing a suit and tie. But crucially, LLMs have absolutely no way to make this distinction. That's because everything that winds up in the underlying X in their models is based entirely on distributional evidence. In this snippet from a piece of fiction, for example, distributional evidence provides no way to tell those three apart. As far as the LLM is concerned, everything is the same color. So when you're optimizing cross-entropy, all these different kinds of evidence about the concept of nurse are going to be treated in exactly the same way. They're going to be woven together uniformly into a huge, impenetrable, parameterized web of associations and inferences connected with the word. Now, in the paper, I discuss how this is related to the distributional hypothesis. We all know J.R. Firth said, "You shall know a word by the company it keeps." Firth was emphasizing the very real relationship between distributional use and meaning, but his quote has been consistently taken out of context. His actual thinking was more nuanced, and neither he nor Zelig Harris, nor the early innovators in statistical NLP were arguing for what we've got today, a radically strong version of the distributional hypothesis, where the idea of meaning is defined by and only by statistical distributions in corpora. Now, you might be thinking that reinforcement learning from human feedback is a way to solve the problem. In the paper, I give a detailed argument with supporting evidence about why that isn't and can't be the ultimate solution to this problem. So where does that leave us? We are in an unprecedented situation where a radical set of assumptions about distribution and meaning are driving practically everything in NLP. And the ability to build comparable, competitive models rests entirely in the hands of a tiny number of players who are making billions of dollars by leaning heavily into the current paradigm and not questioning the assumptions. So we've converged on a kind of model where the fundamental assumptions can't be challenged in a productive way. If you look at this conference, you'll find paper after paper, instead of challenging the underlying assumptions, living within or working around those assumptions. That is not a good thing for the science or for society. So that's the summary of the argument. In the paper, I go deeper, and I suggest some things that might help us as a community get past where we are. If you're feeling like you disagree with part or even all of what I've said, that's fine. I encourage you to read the paper, which already includes a bunch of objections after the conclusions from smart people, and my responses to those. My primary goal here is not to be right. It's to get people talking about things we should be talking about. In particular, my hope is that we'll move beyond just bias mitigation to a deeper discussion of why LLMs are biased in the first place. If this paper provokes debate, that's good. There's a problem here, and talking about it, or even arguing about the roots of the problem, is a good step toward expanding the space of solutions that might get explored. Now, the paper opens and closes with a fable called The Scorpion and the Frog. You should take a moment and read it. Bias in large language models is not a bug. It's actually a fundamental part of what they are, for good and for bad. It's in their nature.